welcome to CH4S. Today we will be solving few reactions which have appeared in NET exam. So here in this reaction, 2-amino-benzoic acid is reacting with sodium nitrite in the presence of HCl is giving an intermediate A. Now this intermediate is further reacting with conjugated diene will give a final product B. So now here we will find both A as well as B. For that, here first NaNO2 will react with HCl when nitrogen here carrying a positive charge will take the bond from sodium and will leave sodium in the form of Na+. In the same way, chlorine here will take the bond from hydrogen, leaving hydrogen as H+. This H+ will form a bond with negatively charged oxygen, giving us HNO2, and sodium and chlorine are eliminated as NaCl. Now in HNO2, oxygen here will take the bond from nitrogen and will leave as OH-, and nitrogen here will get a positive charge. Now the nitrogen present in 2-amino-benzoic acid having lone pair of electrons. These lone pair of electrons will form a bond with positively charged nitrogen and gives us this structure. Here oxygen will take the bond from nitrogen, leaving nitrogen positively charged, and oxygen here will get a negative charge. As nitrogen here is getting a positive charge, the bond between nitrogen and hydrogen is shifted here, forming a double bond between the two nitrogen, and hydrogen is eliminated as H+. Now this H+ will form a bond with negatively charged oxygen, giving us this structure. Here oxygen will take the bond from nitrogen and will leave as OH-. Then nitrogen here will get a positive charge. As nitrogen here is getting a positive charge, the bond between nitrogen and hydrogen is shifted here, forming a triple bond between the two nitrogen, and hydrogen is eliminated as H+. Now H+ and OH- will come out as water molecule and diazonium ion is obtained here. So the whole reaction taking place here is diazotization reaction. And then further, the nitrogen here, which is positively charged, will take the bond from carbon and will leave as N2, and oxygen here will take the bond from hydrogen, leaving hydrogen as H+. So here oxygen is getting a negative charge, and here carbon is getting a positive charge. As carbon here is getting a positive charge, the bond between these two carbons are shifted here, forming a triple bond, and here carbon is getting a positive charge. Then the extra electrons which are present on this oxygen is shifted here, and carbon dioxide is eliminated. And here an intermediate benzene is obtained. That is, A is an intermediate in this reaction, which is a benzene. Now benzene further reacts with conjugated diene. Here further we can see another reaction, which is Diels-Alder reaction. That is, diene and dienophile, when they react, they give a Diels-Alder adduct. Here in this reaction, from dienophile, this bond is shifted between these two carbons like this, in this way, and this bond is shifted between these two carbons in this way, and now this bond is shifted here, forming a double bond between these two carbon atoms. So this is Diels-Alder adduct, which is a final product B. So in this whole reaction, two types of reactions are seen. Here diazotization reaction as well as here Diels-Alder reaction. Now let us see the next question. Here uridine first undergoes nitration followed by reduction in the presence of tin and HCl gives a product X. Now let us find the product X. For that, first H2SO4 will react with HNO3, where oxygen in H2SO4 will take the bond from hydrogen, leaving hydrogen as H+. This H+ will form a bond with the lone pair of electrons present on the oxygen and will give us this structure. As oxygen here is containing a positive charge, it will take the bond from nitrogen and will leave as water molecule. This negatively charged oxygen will donate its extra pair of electrons to the nitrogen, forming a double bond. This compound is called nitronium ion. Now this is the structure of uridine. The double bond present in uridine is shifted to this carbon where a negative charge is obtained on it, and this carbon will get a positive charge. Now the nitronium ion will form a bond with negatively charged carbon and gives us this structure. Here nitrogen is containing 5 bonds. That is the reason why it is carrying charge 2+. Now the oxygen here will take the bond from nitrogen and will get a negative charge on it, and the charge present on this nitrogen is changed to 2+. So here 2+ is changed to 2+ here. Now the oxygen here will take the bond from nitrogen and will get a negative charge on it. As carbon here is having a positive charge, the bond between this carbon and hydrogen is shifted here, leaving hydrogen as H+. This H+ will form a bond with the lone pair of electrons present on the oxygen and will leave as H3O+. Now we will get this structure. Here, as place is insufficient, I have written only a part of the uridine where the reaction is taking place. So now, the forward reaction is taking place with the help of acidic hydrogens. As there are 2 negatively charged oxygen, each of the acidic hydrogen will form a bond with them and will give us this structure. Now this structure will undergo reduction in the presence of H2, where oxygen here will take the bond from nitrogen and will leave as OH-. As nitrogen here is getting a positive charge, the hydride ion will form a bond with the nitrogen and gives us this structure. This structure again undergoes reduction with H2, where oxygen here will take the bond from nitrogen and will move out in the form of OH-. As nitrogen here is attaining positive charge, the hydride ion will form a bond with nitrogen and will give NH2 at this carbon. We will get NH2 at this carbon. Now X is the final product which is obtained here. So in this reaction, we have came across with 2 reactions, that is nitration reaction as well as reduction reaction. Reduction reaction is seen when NO2 is converted to NH2. Now let us see the next question. Here iodobenzene reacts with 2-propyl-1-ol in the presence of LiLH4 and gives a final product A. Now let us find the product. Here iodobenzene reacts with 2-propyl-1-ol where iodine in iodobenzene will take the bond from the carbon and will leave as I-, and this carbon will get a positive charge here. The carbon present here will take the bond from hydrogen and will get a negative charge, and this hydrogen will leave in the form of H+. Here this negatively charged carbon will form a bond with positively charged carbon and gives us this structure. Here the bond present between these 2 carbons, that is the pi bond, will shift to this carbon, leaving this carbon positively charged, and this carbon will get a negative charge on it. This compound will undergo reduction in the presence of LiLH4, where lithium here will get a positive charge, AlH4 will get a negative charge. The hydride ion from this AlH4 will form a bond with the positively charged carbon atom and will give us this structure. This structure will again undergo reaction with acidic hydrogen where the H+ will form a bond with the negatively charged carbon and gives us a structure which consists of 2 forms. One is trans as well as cis. As we know that trans alkene is more stable when compared to cis alkene, this trans product in this reaction is considered to be a major product. Now let us see next question. This compound reacts with sodium thiophenolate and gives a product. Let us find the product. In this compound, oxygen here will take the bond from carbon and will get a negative charge, leaving this carbon positively charged. In sodium thiophenolate, sulfur will take the bond from sodium and will leave sodium in the form of Na+. Sulfur will get a negative charge. Now this negatively charged compound will form a bond with this positively charged carbon and will give us this structure. Now this compound in the presence of acidic medium will react with H+ where this H plus will form a bond with the negatively charged oxygen and gives us this structure. So this is the final product obtained in this reaction. Now let us see the next question. So what is the product formed in the reaction of glucose with benzaldehyde in the presence of para-toluene sulfonic acid? So here first we will be taking the chair conformation of D-glucose and benzaldehyde PHC double bond OH. Here oxygen in benzaldehyde will take the bond from carbon and will get a negative charge on it, and carbon here will get a positive charge. The oxygen present at 6th carbon will take the bond from carbon and will leave in the form of OH minus, where the carbon here will get a positive charge. The oxygen at 4th carbon will take the bond from hydrogen, leaving hydrogen in the form of H plus, and this oxygen here will get a negative charge. Here water molecule is eliminated. Now this negatively charged oxygen in glucose will form a bond with the positively charged carbon in benzaldehyde, and the negatively charged oxygen in benzaldehyde will form a bond with the positively charged carbon in glucose, giving us a cyclic compound like this. In this structure, this pH is present in equatorial position because the equatorial position is considered to be more stable when compared to axial position. So this is the final product obtained in this reaction. So today we have discussed a few questions. For more sessions, please do like, share and subscribe our channel.